But anyway, this is a soothing place. This is a stimulating place. We are all privileged to be here. It's amazing how much wonderful work has gone on in the Whiteside Museum. There are animals there that are new species. More important than that, there are better samples of animals that we've known for 100 years. There's not one, not two, not three, but 5 members of the Dimetrodon family there, doing different things. It's like in certain parts of Africa, you can find a leopard, a cheetah, lions, big hyenas. You can find 5 big, pretty powerful, active predators back then in the early Permian. So it was here. I saw the word Seymour and Baker in the label. I read the labels of the red bed specimens in New York. They had come from here or nearby, collected for Professor Cope at Philadelphia, and the American Museum bought his collection and curated it and cleaned it up more. And there's also a couple of folks who gave their life for red beds, Texas paleontology. Jakob Boll is another guy whom you should know, B-O-L-L, Jakob Boll, a Swiss-trained naturalist, field naturalist, and physician. Came down here to collect red beds fossils. He found the first Dimetrodon skeleton, nearly the whole thing, small species. And anatomical drawings were made, and they made the front page all over the world. This thing with a fin and saber teeth, a predator, totally unknown group of critters from around here. Jakob Boll. He was in his collecting outfit a little east of here, and he had collected a wonderful Uriops, a great big alligator-headed amphibian. And it was nailed by a Texas rattlesnake, big one, diamondback. He knew enough medicine that he knew he was going to die. And he sat down on his bunk and made sure that every single specimen had a label, careful label, well done, and wrapped them all up. And then self-medicated with some schnapps, and sat down and wrote a poem in German. And all of these things, the labels, the fossils, the notes were found after he died the next morning, and his body eventually made it to the Texas Cemetery of Heroes near Dallas, Jakob Boll. And he was responsible for at least 5 new kinds of animals collected from around here, which he sent up to Professor Cope, who got his illustrator to show what they were like. So a hat off to Jakob Boll, a great man. So this will change you to be in this. Could you skip that? Go to the next slide. Philosophically, in your own mind, or teaching, or speaking, or just ruminating, where to put our red beds animals in the history of life and the purpose of life. This is a Dimetrodon from earlier beds, from the Wichita beds, but similar to the guy you have, biting a 2/3 grown Uriops in Al Romer's, the professor at Harvard, Al Romer's office. There were drawers and drawers and drawers of Uriops, and I went through measuring them all. And one Uriops had a diamond-shaped wound in the arm, a deep wound, a peculiar shaped weapon. It matched a Dimetrodon canine tooth. So we have forensic evidence that this happened. How often did it happen? Next slide. This is one of the top predators from the late Permian, from the beds that Olson and many others sampled in South Africa. It's a gorgon. It's got one big killer canine, and it's often illustrated as being ugly and naked with no covering. I think that's wrong. I think the evidence now is that there was a revolution in the late Permian that the Texas redbeds animals, some of them, evolved a fur covering. There is some fur in a fossil turd from this predator. It could have come from the predator or from its prey, which was a herbivore relative. But right now, this is the the most talked about handful of crap because there's a hair in it. Because there's a hair in it. Next. This is a very good painting of a saber-toothed gorgon, a direct descendant of Dimetrodon, the Dimetrodon family, which is huge canines, the first saber-toothed animal ever. And it came from ancestors of Texas redbeds, predators. Next. Okay, to put things in context, let's start, say, 1820. When paleontology was just beginning. The yellow guys, the age of mammals was well represented. Mammoths and mastodons and saber-toothed cats and hyenas and cave lions. This was well documented actually by 1790 by French paleontologists. Below it is the age of reptiles, so named by Professor Cuvier in Paris. A longer period, more complex. Megalosaurus, the first dinosaur meat eater. Good specimens have been found by a British and described in 1820. And there were plant-eating dinosaurs too, and the suggestion of Triassic dinosaurs. So we knew the overall population of extinct critters for age of mammals, age of reptiles. Now go back to around 300 million. There were fossil fish beds in the Devonian age of fishes. In between, the guys there on red hadn't been found. There was a gap, a huge gap. What came before the age of reptiles? Interesting. Next. Next. This is Al Romer. I was his last student, one of his last students. He dearly loved Dimetrodon. On the door of his office was painted a picture of a Dimetrodon wearing a pith helmet, digging up a human skeleton. He also named many fossil animals. One from near Archer City, he named Stereophalodon, which was the big predator before Dimetrodon. There's only one good specimen. We should all go to the Archer City bone beds and work it. They used to have a museum, they lost it. And Larry McMurtry moved. Next slide. This is really where the concepts get focused. The very young Queen Victoria, and she was tiny as a young queen. She also loved animals. She started the Royal Society for the Prevention of Cruelty to Animals. So there. And the Prince Consort, Prince Albert, scientifically educated. A great book came out in the mid-1840s called the Relics of Creation. And it was a history of fossils and living animals put in the context of progressive creation. These two people bought a copy and talked about it to each other in the evening. I'll tell you, this was a time of a wonderfully productive royal family. And they brought in the young Professor Owen, paleontologist, British Museum, and he gave lectures and demonstrations to their two kids in the palace. And Prince Albert persuaded one of his kids to take the trip all the way to South Africa to get a skull for Professor Owen. And he went all the way down and did get a skull and came back up, and it's on display in the museum. Owen worked his whole life for a museum building, and hard work, but thanks to the connection with the Empress, the Queen, and the consort, he saw the museum building finally built in the 1870s before he passed on to his reward. Anyway, these are two great movers and shakers in the history of museums and the history of museum education. Next slide. Okay, now one thing they discussed was classes. Since the time of Aristotle, maybe before, nature was seen, was interpreted in classes, low classes, high classes. eagles, birds were very high class. If you cut into them in an anatomy class, you see a gigantic heart, bigger for its weight than ours. A fantastic system of lungs, better than ours. And there's 11,000 species of birds. This is a very high class. Next slide. And then there's our class, the milk-bearing, fuzzy outside mammalia. And since the royal families were mammals, they're rated even above birds. And when did they show up? And there was already some disturbing news. In 1818, digging megalosaur, Jurassic dinosaur, professors at Oxford found tiny, tiny jaws. They were undoubtedly furballs. They were mammals. They're part of the highest class. But they were tiny. There was a variety of them, but they were all small. And the dominant animals were these high-class reptiles named dinosaurs. Interesting. Next slide. There are lower classes, of course. This is available in t-shirt form. It's very popular with Bronco fans. The lizards, the snakes, are lower class. They were part of your anatomy class when you did university. And you cut into a lizard, and the heart and lungs are very small and very weak and can't pump blood 1/20th as powerful as a bird or furball. The brain is very tiny. When kept as pets, they seem relatively unresponsive. I've been bitten more by lizards than any other class. And many of the ocean-going extinct reptiles were considered some sort of lizard. So that's a low class. Next slide. And there's a sidebar here. The crocodiles were recognized as a lizard adjacent, but you cut into a crocodile or an alligator, the heart's pretty dang big and divided into 4 good chambers, such as ours, and the lungs are pretty darn good. And there was already reports from alligator hunters in Louisiana that the alligator mom is a dutiful mom, and that's absolutely true. So you did have a higher class development within the low class. That's cool. Excellent. And then there are the soccer hooligans. It's the lowest class, the amphibia, with tiny brains and tiny lungs. And some of the salamander amphibians have no lungs at all, and appropriately they're called the lungless salamanders. But there are a lot of them, thousands and thousands of species, and British naturalists coming back from Costa Rica said, it's hopping with frogs. Low down there, next slide. Okay, now a guy who came out of the Royal Navy, serving as a naturalist on the HMS Rattlesnake, kind of like Darwin served on the Beagle, Thomas Henry Huxley, the oldest of the Huxley clan, and he was interested in the lowest class, the amphibians. He was the first to spend a decade and a half of his life looking at all the fossil amphibians, and some of them were rather spectacular. There's a thing called we don't have it in there. The big guy on the bottom is an embolomeer, and it's got saber teeth. It's the first saber-toothed frogoid, or what I call an FOK, friend of Kermit. Big, dangerous, swimming, cut-tooth predator, and he described it. And he found and worked on many other small and medium-sized amphibians, including the guy standing on his head, Amphibamus, very strong legs, and clearly terrestrial in habit as an adult. And he asked himself, which of these amphibians became a higher class, a reptile, something that could lay eggs on land, not water, and become active through its whole life on land, which one here? And which frogoid became a mammal? And he decided it was one of his crowds. Next slide. Meanwhile, in London, that's Professor Owen, the genius behind the new British Museum, and he was doing the late Permian. Hardly anyone else was. He was doing the late Permian. And he was finding a menagerie of bizarre animals, some of which were quite huge. The one he's riding is Titanosuchus. It's an animal probably a ton. The first animal on land of a ton, and strong legs. And the two tuskers, Dicynodon, that's the one that the royal prince brought back from South Africa. And there's a gorgon there, which had been brought from South Africa too. There was a whole menagerie of animals. And Owen was careful when talking about evolution. He didn't want to scare people. But he suggested what he thought, what he believed, with the names. Like, there was the weasel lizard. He would combine a low-class name, lizard, with a high-class name, a weasel. And he would do that with the wolf lizard, too, Theriosuchus, and the gorgon face. He was communicating subtly that there was a time when the low-class reptileness was being overridden with a higher-class mammalness, and most of his colleagues either disregarded it or attacked him. Unfortunately, Professor Owen, though a brilliant anatomist, was a first-class jerk. He would publicly attack people who were poorer, less well endowed with funds, and unnecessarily attack colleagues. And he attacked the Thomas Henry Huxley. But anyway, he was suggesting something that people were not getting. Next slide. Okay, this is a mounted one of Titanosuchus, one of Owen's weird animals. What we call now mammal-like reptile. That's on exhibit in South Africa. That's a huge dude. That's a ton of plant-eating, sort of hybrid critter. Next slide. Okay, and if you do a modern reconstruction of some of these giant hybrid partial mammals, they're scary. These are both nearly a ton. The one on the right is Ankylosaurus, South Africa again, although its kind is all over the world. Well, and the one it's biting is a bonehead, Tapenekephalians, which put thick lumps of bone over their brain for biting each other. And these guys ruled the world in the next wave of change after the Texas redbacks. This is the next wave. Next slide. Okay, here is Dimensionon. Dimensionon was discovered in 1787, and by 1884 there were a dozen skeletons of 5 different species. Interesting guys, and they have a first tooth, the first upper tooth, and the incisor, which is strong and circular in cross section. Then the more posterior teeth are compressed side to side and saw-edged for cutting things apart. Interesting guy. Plus, there's that hole behind the eye. That's an important hole. Next slide. That hole is what we often say, and we need a drum machine. That's the hole of destiny. Because you have it right behind, right in front of your ear. Place your finger gently right in front of your ear, behind the eye. There's a depression. There's a hole. That hole is full of your jaw muscles. You know, at lunch, please practice chewing on something hard and then feel the muscle contracting. It's a hole. That hole is present in dogs and cats and cows and bats and okapis. name your favorite mammal. It's got the whole. What's your favorite mammal in Africa? Naked dune mole rat. Excellent choice. Very intelligent, lives underground, doesn't have hair, it's got that hole. Whales have that hole, everyone's got that hole. To find the ultimate ancestor of the high class, you find the first animals with that hole. You find the first animals with that hole here. It's called the lateral temporal fenestra, and it's here, and it was described by Professor Cope from Texas Redbeds Animals. Next slide. Here's the lower jaw of a dimetrodon, and in the back you see a notch, a funny notch in the jaw. You have that notch. It's inside your ear. That notch is the ectotympanic. It's holding your eardrum right now. The first animals to have the ectotympanic, the eardrum holder, are Texas Redbeds animals, early Permian. Next slide. Okay. Professor Cope was delighted with these holes of destiny and wrote about them eloquently. And unfortunately, for reasons I don't understand, most of his colleagues said, nah, holes, schmoles. They don't mean that much. Next slide. Well, dinosaurs have two big holes behind the eye. Two holders. And even as juveniles, they had two holes. And you can see that easily in the T-Rex skeleton at the Whiteside. Next slide. Now there is an unfortunate detour. You have this story of a mammal hole in the side of the head and a mammal notch in the jaw for the eardrum, both being identified in Dimetrodon and its skin from fossils right here and nearby. So everyone should have said, oh, the mystery is solved. We came from these redbeds animals. But then New Zealand intervenes. In New Zealand, there is one animal, this is its head, alive today, it's a living animal, the tuatara. The tuatara has a skull, big eye. You notice that big hole right behind the eye, fine. But wait a minute, it's got an extra hole. You can see it, extra hole at the top of the skull. So it's a two-holer. Wow, okay. And it's very primitive in the rest of the skull. So scholars would say, we all must have come ultimately from a tuatara, because that's the most primitive living reptile. Next slide. Here's the top view of an early archosaur, a distantly related contemporary animal. You can see the eye and the lateral hole, which we have, the mammal hole, and then the extra hole in the top. Well, T-Rex is like that. So the little endangered species, the tuatara, was dissected and inspected and rejected and monographed, and they're beautiful books with pictures of the thing. And it led to a false conclusion that not only do we come from something like the tuatara, but we come from something with two holes. Next slide. Now, this brings up a delicate subject, because the tuatara is lacking many things that adult reptiles have today. And one, to be brutally frank, and we tend to be that way, it is dickless. There is no male organ. It's not well hung, it's unhung. And when the first naturalist pulled up a sphenodon and cut into it, the male, there was nothing there. So, all right, a new modification to the theory. We evolved from reptiles that were laying eggs on land. Okay, they're that advanced, but small brains, which had not yet evolved a sophisticated, efficient way of using plumbing in reproduction. And I even heard that from Al Romer. So this is my interpretation of a middle school Dimetrodon, learning that it's outfitted like a tuatara. And though not widely published, this thing ruled for a century, till about 6 years ago, century. You cannot dissect a pickled, alive tuatara, too rare, they're protected. But you can dissect a pickled one, pickled way back in 1880. And that finally happened, including one up at Harvard. And when they dissected the male, okay, it was not equipped with obvious mature apparatus, but there was a lump in the floor of the rear of the anatomy. There was a lump, and they sectioned the lump. It was full of cells that were dividing. One of the greatest mystery, and I have no suggestion, is that the tuatara evolved from an ancestor that was fully equipped. And the male organ does develop to a certain part of the anatomy and stops. It just stops. And there's no more. That happens in songbirds, by the way. In 10,000 species of songbird, there is no penis. There's none. The argument is, well, it's dead weight, it's more important to fly. The tuatara didn't fly, doesn't fly, never had a flying ancestor. Why the heck did it suppress the male organ? We don't know, but it happened. Did Dimetrodon go through this sequence? Next slide. This is the head from the top of Dimetrodon. The bones above the eye colored. Those bones are damn thick. These are the upper eyelid, upper eyebrow bones. They're like armor. They're really thick. And there is no upper hole. The guys were wrong. The theory was wrong for half a century. They were inventing a hole that doesn't exist. You have to stick a knife in the skull and move these skull bones around to make a fake upper hole. Interesting. And poor Professor Cope spent his whole life arguing against the phantom hole. No, our ancestors have been one-holers, proud one-holers for their entire life and are not close relatives of the dickless tuatara. Next slide. Okay, let's talk about the teeth. That big, strong fang up front and the cutting fang in the rear. Next. Here is a jaw of a baby Dimetrodon, about the third grown, and it shows the killing fang and then a long row of cutting teeth. Next slide. And these teeth were replaced, were renewed all through life. The tooth socket was a factory of teeth, like the magazine of an old tubular rifle. New teeth were forming in the tooth socket, or when the functional tooth is broken or worn out, falls out, and there's another one. They never run out of teeth, ever. Most animals are like that. They're not like us. We have adult teeth, that's it. Nope. Dimetrodon never ran out of teeth. New ones being produced in every tooth socket. Ooh. And when the tooth is lost, when it's lost from the jaw, we call it a bullet, because it tells you who is feeding on whom. Next slide. Here's a T-Rex, the jaw near the chin, and you can see new teeth coming in and growing in through the root of the functional teeth. This happened all through life, they never ran out. One thing, one part of my crew's new tradition is to get on your hands and knees and pick up every shed tooth, because that's a bullet. It had been used for feeding. Next slide. Now, we have done some stuff with fossil crocodiles and their shed teeth. Living crocodiles are sophisticated. The big males are separate from the breeding females and the babies, and you should find some segregation of shed teeth, and we do. There's several thousand Jurassic crocodile teeth. In Bygone, their society was like crocodiles. Next slide. That's the inside of an Allosaurus jaw, showing the teeth growing in through the socket. We've done the same thing with Allosaurus. We have several hundred shed Allosaurus teeth from Wyoming, and it looks like the babies and the adults were all feeding on the same thing. The babies weren't feeding on baby food, they were chewing on giant hunks of adult prey, much like an eagle feeds on adult prey brought to the nest. Well, it looks like Allosaurus, at least, did that. Next slide. That is a baby, probably newborn Dimetrodon tooth. That guy would be only a couple pounds tops. And you can see it's already serrated, it's very sharp. And that was found among chewed bones, right here in Seymour, chewed bones of various prey, and shed teeth of adults. Circumstantial evidence that mom and or dad were feeding on the same food as their kids. Next slide. So this would work if you imagine that's mom there bringing home Uriap steak for the kids for that evening. Next slide. Now, in one of our beds, and some of you dug there the other day, one of our beds, there's lots and lots and lots and lots of chewed up shark, freshwater shark, and there are occasionally shed teeth of Uriaps, the big alligator-headed amphibian, that's the guy on the left. And with these chewed up sharks, there are Dimetrodon shed teeth. And there are thousands of chewed sharks in this bed, thousands. So Dimetrodon, among other things, was feeding on the shark, the other white meat. Next slide. Next. What about the herbivores? Ecosystem has to have herbivores. We do find herbivores shed teeth. That's hippie teeth, front tooth of Diadectes, a big plant eater. And the museum has wonderful specimens. Next slide. And we have more than shed teeth for Diadectes. One of our colleagues is attracted to really ornamental, instructive crap. And he found these footprints, which are for Diadectes, they're broad feet, broad claws. And right next to it, next, was this wonderful piece of crap. That's herbivore crap, that's herbivore poo. In fact, there's a poster you can sign away for, which will allow you to classify your own poo. And there's a whole system of vegans that exchange pictures of poo. This is the number 6, by the way. It's liquidy, it comes out in a ropey thing, not lumps, not dry, but not diarrhea. This is number 6. And I want all of you to try at least, just have one. This wonderful poo. Could you back up one? Back up one. There. Those two Diadectes plant-eating footprints were found right next to, okay, one forward, this number 6. We were looking for a little table with a Sports Illustrated, but couldn't. This is one of the few cases where the footprints confirm the identity of the shitter. So yes, there are things eating plants, and digesting plants, and processing plants, and pooping plants. But, here's a huge but, you may want to write this down, huge but. Although the herbivores existed and left footprints and left shed teeth and left number 6 poo, they're incredibly rare here in Baylor County, or the next county, or the next county. Herbivores had evolved. Today, if you go to Africa, you expect to see maybe 1 lion for 50 antelope and zebra. Overwhelmingly plant eaters. Here, and you can check out the exhibits, it's the opposite way. There's 100 meat eaters, Dimetrodon, per single didactic. It's upside down. The ecological pyramid is upside down. And it's that way for about 10 million years. Next slide. That's the front end of didacties with the broad guts for digesting stuff. Next slide. So we have didacties. Chris dug a didacties that had been bitten in the snout in the front, apparently pulled out of the ground by its snout. That is a very common scenario today in animals that hide in burrows. This is from the White River Formation. That's an ornodon, the guy. The red guy is a plant eater, and it's a saber-toothed cat and a burrowing tortoise. If you're specialized to grabbing things by the snout and yanking them out, next slide, you're going to produce a lot of bites in the head. The red bone is the back of a Dimetrodon skull, brain case, and it's got bite marks in it. And there's the close-up of one of the parts of the brain case showing the bite. Dimetrodon was feeding upon Dimetrodon very heavily. The average Dimetrodon died and was chewed by other Dimetrodons. Next slide. Here is this famous Diadectes, it's on exhibit, where the whole front of the snout had been bitten and ripped off, and the animal died. And the body pulled out of its burrow. It probably was a burrow hider. Next slide. Here is my favorite fossil in the entire museum here. This is Ashaloma, and as projected, it's about 5 times natural size, about the size of a big woodchuck. It's an amphibian, lowest class. Very strong legs. As an adult, it was living on land, and probably in burrows. Next slide. Here is its snout. You see all the crush marks in the snout in front of the eye sockets? The crush marks are circles. Something with powerful circular teeth was biting the heck out of the snout and probably pulled the animal out of the ground with those bites. Next slide. Here's a close-up of the bite. This is a fabulous CSI, and those bite marks match that first big upper tooth of Dimetrodon, your ancestor. Next slide. Here is a femur of a Dimetrodon. And see that bite? That lenticular bite mark? That fits a posterior tooth of Dimetrodon. Next slide. Here is one of our skeletons called Willie, and it's the entire tail had been bitten off, and there are bite marks there. Next slide. Here's a close-up of 2 neck bones. These are the bones right behind the head. 2 different species of Dimetrodon. The one on the left had been bitten. There's lots of muscle in the neck, and someone had bitten a lot of it. Next slide. Here is a lower shoulder bone, coracoid. See all the notches along the bottom edge? Nip, bite, nut, bite, then all along the edge. That's what you do to remove a big hunk of muscle. Next slide. Here's a shoulder, and it's just the rear of the shoulder blade. The front, which is in blue here, has been bitten away. Next slide. Here's a baby Dimetrodon, complete upper arm bone on the left, and another one on the right. Both ends have been bitten off, leaving only this shaft. We call this the endless shaft, which we often get from government bureaus. Next slide. Here is a very good, slender baby Dimetrodon humerus that's been bitten off from the top and the bottom and the side. Next slide. Here is a hip, and all of the little tiny arrows show bite, 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 bite. There's lots of muscle there. Dimetrodon is biting, not randomly, not coarsely, but where it would get the most meat from each bite. Next slide. Here's another hip. This is from a Cecodontosaurus. There are massive bites in the bottom, and the top of the hip, little bites all around. Next slide. Oh, I love this one. This is a femur of a 2/3 grown Dimetrodon, and the shaft and the lower end are pretty good. But up towards the top, the entire upper end, the joint end, has been bitten away. Now, you can get the same effect with most dogs and a bone from the butchers. Dimetrodon was a precision biter, a precision excavator of meat. Next slide. So, cannibalism sometimes strikes a disturbing note, but in fact with our allosaur discoveries in Jurassic, it's the same thing. Most allosaurs were chewed up by other allosaurs. Cannibalism is just intelligent recycling. And lions do it, hyenas do it, Lutherans do not do it. But Dimetrodons did this. Next slide. And it reciprocates. I talked about the sharks being eaten by Dimetrodon. It ate sharks. It ate lots of freshwater sharks, lots of freshwater fish. And the shark sometimes ate the Dimetrodon. It's a Dimetrodon thigh-bone with long scrape marks, which are classic shark remnants. Next slide. Okay. So we're halfway there to supply Dimetrodon with food. That is not herbivorous food. Here's a boomerang head. We love these guys. Flat-headed amphibians. Next slide. Here's the growth from a little baby to half-grown and full-grown. The one on the top is the biggest one I know. And these guys are really common. Next slide. And they were bitten and pulled out. Next slide. Here is one, and on the left you can see the snout has been bitten and animal killed with a snout bite. Next slide. Here's the total body of a boomerang head, Diplocaulus. Next slide. And they're found all through the channel deposits, the rivers. And most of them have been bitten by Dimetrodon. Next slide. Okay. So the mystery of the missing plant eaters, I think, is solved. Dimetrodon was designed and had the behavior, and did it very efficiently, to attack watery, non-marine prey. The freshwater sharks, like these guys, and other freshwater fish. Bottom-living amphibians, like a boomerang head. Big amphibians, like Ariaps. Occasionally big herbivores, but it could survive without them. This ecosystem lasted about 12 million years, where the herbivores were just about irrelevant. Present, but irrelevant, like vegans in small towns in Wyoming. Next slide. So, back to our guys, to Sir Richard Owen, the paleontologist who gave lectures to the royal family, and got the royal family to support the building of the British Museum. And he accumulated a lot of late Permian critters, who, when compared with our early Permian, make a continuous story. It begins here. The ecosystem, first one was set up here, and then finally the late Permian, you had a normal one with lots of herbivores. Anyway, that's the end of the tour, and what you have done, you the people of Baker County have done, supporting the museum is extraordinary, and what the museum people have done is mind-boggling, and is teaching the entire world something fundamental about our history. So I don't ask any of you to become vegan or cannibals, but do go through the museum again and tip your hat to our ancestral group, the Dimetrodons of Ignax, who made a living, and a good one, by feeding off aquatic prey and set up the evolutionary simulation for the great late Permian explosion that Professor Owen described with many herbivores. Anyway,